Today's lesson is going to be on the metric system. Now, in the United States, we do typically use a mixture of different systems. For example, we may measure a distance in inches or feet, but then you also go to the grocery store and you might purchase a 2-liter of your favorite soda. So inches and feet are the English system, and the 2-liter is the metric system. In science, we have decided that we will use the metric system because the majority of the rest of the world uses the metric system. So by scientists also using the metric system, it allows for communication between other scientists in different countries to be much easier in terms of different measurements. So here's what we are going to do. We're going to start by looking at our different metric conversions. Okay. We have mega, kilo, hecto, deca, and the base. And then we can go to deci, centi, milli, micro, and nano. Now, these are not all of the metric units. They're just the most commonly used ones. And so that's what we're going to stick with in this class. There are more. So let's come back up here for mega. Mega has a symbol of capital M. And our conversion factor for mega is 10 to the 6. Kilo has a symbol K, and our conversion factor is 10 to the 3rd. Hecto has a symbol of H with a conversion factor of 10 to the 2nd. Deca is DA with a conversion of 10 to the 1st. And our base unit, the base unit is going to be, if we are in distance, we would use meters, which is M. If we were looking at volume, we would use the L for liters. If we were looking at time, we would use S for seconds. And if we were dealing with mass, we would use G for grams. Now, everything above the base unit is larger than the base unit itself. So mega, kilo, hecto, and deca are all larger than the base unit itself. All right, so we'll write that down. Now, everything below the base, deci, centi, milli, micro, and nano, these are all smaller than the base. Now, why is this important? When we are doing a conversion factor, the larger value always gets the 1. And we should probably not use the word value. Let's use the word unit. The larger unit always gets the 1. All right, now why is this important? So we're going to do some practice problems here, and we're going to use our chart. Before we do so, we want to finish filling in our chart so that we can refer back to it as we do some practice problems. The symbol for deci is a D, and its conversion factor is 10 to the 1. Centi is a C with a conversion factor of 10 to the 2nd. Milli is a M with a conversion factor of 10 to the 3rd. Micro has a symbol, all right, and it kind of looks like a funky U type symbol, all right? So we've got this micro symbol, and its conversion factor is 10 to the 6. Nano is an N with a conversion factor of 10 to the 9. So we're going to come over to our worksheet. And we're going to look at some metric conversions. 77.5 liters to kiloliters. So in this worksheet, we are going to write what we are given, which is 77.5 liters, and liter is a capital L. All right, and that's how we measure volume, okay? So liter is a capital L. Now, to do a conversion, I'm going to draw a line. All right, this line symbolizes the multiplication symbol, and the horizontal line symbolizes a division symbol. When I set up my conversion factor, whatever unit is on top also goes on bottom. Now, you must always have a base in every single conversion. Liter is the base unit, and because I already have the base unit in this conversion, I can go direct to kiloliters. And we saw that kilo had the symbol K, so I'm going to write a K for kilo and an L for liter. Now, we also saw that the larger unit always gets the 1. So when I'm looking at my chart, out of the kilo and the base, which is larger? Kilo is larger than the base. So kilo gets the 1. The conversion factor I put with liters is going to be the 10 to the 3rd. Now, there's several different ways to do this. Sometimes I've seen it taught with negative exponents. I like to do it this way, with the larger gets the 1. I find students are usually more successful when they solve this way. So what does this mean? This line, this vertical line, is a multiplication. So essentially what I'm doing here is I am taking 77.5 times 1. And this horizontal line is a division, so I'm essentially dividing by 10 to the 3rd. So 77.5 times 1 divided by 10 to the 3rd is going to be 0.0775. Now, every value must have a unit. If the unit is on the top and the bottom, they are the same, they cancel. Liters divided by liters cancel out. I am left with a kiloliter. So that is my final answer. 0.0775 kiloliters. Let's do us another example. 0.435 hectoliters. So we write down what we are given. The unit on top must go on bottom. Notice I'm setting up my units first. I am not trying to solve and put numbers in. Units always get set up first. Now, in each conversion section, I must have a base unit. Hecto is not the base. Liter is the base. So I have to go to the liters, which in this case is also what I'm solving for. So that works out really well. Now, hecto is above the base. So hecto is larger, and so that is going to get the 1. So hecto gets the 1 because it is larger. What number goes with the liter? And that's my conversion factor for hecto, which is 10 to the second. So again, this essentially is 0.435 times 10 to the second. Divided by 1. All right, so when I take 0.453 times 10 to the second and I divide it by 1, I end up with 43.5. Now, again, every number must have a unit. Hectoliter is on top and bottom, so when you have the same unit on the top and bottom, they cancel out. I am left with L, which is my liter. So there we go, 43.5 liters. Let's do a two-step problem. So we're going to come over here to number 5 on our worksheet, and we're going to do a two-step problem. 0.418 kilometers. All right. So let me set this up. The unit on top goes on bottom. I must have a base in every single conversion factor. Kilo is not the base. Meter is the base. Now, the larger of these two units gets the 1. Kilo is above the base unit, so kilo is going to have the 1, and meter is going to get a 10 to the third. Now my problem asked me for centimeters. I don't have centimeters yet. I went to the meter. So I have to set up a second step. Meter is on top, so it must go on bottom. Because meter is the base, I am able to go direct to the centimeter. Now, the larger value always gets the 1. So when I look at my conversion, centi is smaller, the base is larger. So the base is going to get the 1. The base is the meter, so I put a 1 in front. And so what value do I put in my centimeter? I'm going to put a 10 to the second. So I essentially have 0.418 times 10 to the third times 10 to the second divided by 1 times 1. So when I plug this 0.418 times 10 to the third times 10 to the second into my calculator, I find that my answer is going to be a fairly large number, 41800. Now I also have to put in my unit. Kilometer is on top and bottom. Meter is on top and bottom. So those cancel. I am left with the centimeter. Let us do one more practice problem. 10523 nanoseconds. Because nanoseconds is on top, it goes on bottom. I must always go to a base unit first. So out of the nanoseconds, second is the base. The larger value gets the 1. So when I look, nano is actually below the base. So in this case, the base is the larger value. I get the 1, or the larger unit. So what am I going to put into my nano? I'm going to put in a 10 to the 9. Now, I am in a second, and I want microseconds, so I have to do another step. Second is on top. It has to go on bottom. Because second is the base unit, I can go direct to the microseconds. I have to determine which one of these units is the larger. So when I come back over to my chart, I see that the micro is in fact below the base unit. So because micro is below the base unit is larger. Seconds is the largest, so I give it the 1. And micro is going to get a 10 to the 6. So when I plug this into my calculator, 10523 times 1 times 10 to the 6 divided by 10 to the 9 times 1, I end up with a value of 10.523. And now what are my units? Nanoseconds is on top and bottom. Seconds is on top and bottom, so they cancel. I am left with the microsecond, so there is my answer. Very quickly, let us define what a fundamental versus a derived unit is. A fundamental unit is a unit that you can get directly from measuring it with a piece of lab equipment. All right, for example, the meter. I can use a meter stick to measure how many meters a ball rolled down the lane. A derived unit is a unit which requires math. Unit which requires math. Now, we are going to have another lesson in this particular topic of chemistry on density, and we're going to learn what density is. Density is a derived unit, though. Density is when I take the mass of a substance and divide it by the volume of that substance. So I am actually having to do math to find the unit for density.